You might think the speed of light is simply a number, 299,792,458 meters per second. Fast, really, really fast. It's the fastest thing we know of. Okay, fine, but why is it the limit?
Why can't you go faster? What's stopping you? Most people have never really thought about this. They just accept it. Einstein said so. The speed of light is the universe's speed limit.
That's just the way it is. But that's not an answer. That's just repeating the words. When you actually ask why nothing can go faster than light, when you dig into what's actually holding you back, you uncover something profoundly strange, something so fundamentally different from everyday experience that it changes everything you thought you knew about space and time. The speed of light isn't just a speed. It's not just the fastest thing. It is the very structure of the universe itself. It's woven into the fabric of space and time in a way that makes going faster literally meaningless.
Let me show you what I mean. Let's start with something simple, something everyone knows. Things fall. Drop something and it falls down. Exactly 16 feet, about 4.8 meters, in the first second.
That's what Galileo measured. Drop a ball, drop a rock, drop anything. In 1 second, it falls 16 feet. Now, consider the moon. The moon orbits Earth. It doesn't crash down. It stays up there, orbiting, moving in a circle. But wait, is it falling? Think about it. If the moon were just sitting still in space, what would happen? It would fall straight towards Earth. Gravity would pull it in. But the moon is moving. It's moving sideways, tangential to its orbit. And because it moves sideways while gravity pulls it down, it's constantly falling past the Earth. It falls towards Earth but keeps missing. That is the essence of an orbit. It's constant falling while moving sideways fast enough never to hit the ground. This is where Isaac Newton had his stroke of genius.
The moon is 240,000 miles from the center of the Earth. We are standing on the surface, 4,000 miles from the center. So the moon is 60 times farther away than we are.
Newton asked, what if gravity weakens with distance? What if it follows an inverse square law? That would mean if you go twice as far away, gravity's 4 times weaker.
3 times as far away, 9 times weaker, the square of the distance. If that was true, then at the moon's distance, 60 times farther, gravity would have to be 60 squared times weaker.
That's 3,600 times weaker. Now, on Earth, objects fall 16 feet in 1 second. If gravity at the moon was 3,600 times weaker, the moon should fall towards Earth by an amount equal to 16 feet divided by 3,600.
Let's do the math. 16 feet divided by 3,600. That comes out to about 1/20th of an inch per second squared. Wait, let me rephrase that. In 1 second, an object at the moon's distance would fall towards Earth 1/20th of an inch multiplied by 3,600, because we are talking about time squared in the formula.
1/20th of an inch times 3,600 equals exactly 16 feet, exactly what we measure on Earth. Newton calculated how far the moon would fall towards Earth in 1 second if gravity obeyed the inverse square law. And the result matched perfectly. The moon is falling at exactly the rate Newton's law predicted. This was a massive achievement. This wasn't just speculation. This was a prediction.
Newton took one completely independent fact, which was the rate things fall on Earth, and connected it to another independent fact, which was the orbital period of the moon and its distance from Earth.
2 seemingly totally unrelated things were suddenly connected by a single law, the law of universal gravitation. There was no going back after that. Newton went even further.
He calculated what the shape of planetary orbits would be if gravity followed the inverse square law, and he discovered it had to be an ellipse. And guess what?
Planets actually move in ellipses. Kepler had measured that previously, but Kepler didn't know why. Newton explained it. He achieved a true hat trick. And then more things started to make sense. Tides. Why are there tides? Because the moon pulls on the Earth.
But wait, if the moon only pulled the Earth towards it, shouldn't there only be one high tide per day? That's the bulge of water on the side opposite the moon. But in reality, there are 2 tides per day, roughly every 12 hours. Why? Some people thought the Earth was being pulled away from the water.
Others thought the water was being pulled toward the moon. Both were partially right, but nobody got the whole picture. Newton realized what was really happening.
The moon's force on the Earth and on the water is the same at the same distance, but the water on the near side of the moon is closer to the moon than the center of the Earth is.
So it gets pulled harder, and the water on the far side is farther from the moon than the center of the Earth is, so it gets pulled less. Thus, you have 2 bulges, one where the water is pulled harder toward the moon, and one where the water lags behind because the Earth is pulled harder than that water. 2 high tides per day. Actually, the Earth is doing the same move as the moon. It's moving in a circle. The center of that circle is somewhere inside the Earth. Both the Earth and the moon orbit their common center of mass. If you want to think of it this way, one bulge is thrown out by centrifugal force more than the Earth, and the other is pulled harder than the Earth's average pull.
Regardless, the tides were explained, and the fact that there are 2 of them per day. So many other things became clear. Why the Earth is round, because everything is pulled inward.
Why it isn't perfectly round? Because it's spinning, so the outside gets pushed out a little bit, creating a balance. Why the sun and moon are round, and so on.
As science progressed and measurements became more accurate, the tests against Newton's law became much more rigorous. The first careful tests involved the moons of Jupiter.
By closely observing how they orbited over a long period, one could test very precisely whether everything followed Newton's laws.
And it turned out they didn't always. Jupiter's moons sometimes appeared 8 minutes ahead of schedule and sometimes 8 minutes behind schedule, where the schedule was the values calculated by Newton's law.
8 minutes? That's a huge deviation. Something was wrong. But hold on. It was noticed that they were ahead of schedule when Jupiter was closer to Earth and behind when Jupiter was farther away.
A pretty strange circumstance. Sir Romer, trusting the law of universal gravitation, came to a fascinating conclusion. Light takes time to travel from the moons to the Earth.
And what we are seeing when observing the moons is not their current state, but their state from a while ago, equal to the time it took the light to get here. When Jupiter is closer to us, light takes less time to travel.
When Jupiter is farther away, it takes more time. So he had to adjust the observations for the time difference, and by the fact of how much they were early or late, he was able to determine the velocity of light. This was the first proof that light did not travel instantaneously. Think about what just happened. We found the speed of light not by measuring it directly, but by trusting the law of universal gravitation.
When something didn't match up, instead of throwing out Newton's law, Romer said, "What if light takes time to travel?" And he was right. I bring up this specific issue for your attention because it illustrates a point.
When a law is true, it can be used to find another law. By trusting this law, if something goes wrong, it can suggest another phenomenon.
And if we didn't know the law of universal gravitation, we would have taken much longer to figure out the speed of light because we wouldn't have known what to expect from Jupiter's satellites. This process evolved into a massive wave of discovery. Each new discovery provided the tools for yet more discoveries. And this beginning, the very start of that wave, has continued for the last 400 years as a continuous process.
And we are still riding that wave at high speed right now. But here is the issue. Once you know the speed of light, once you measure it, you start to notice something very, very strange. Light always travels at the same speed. Always, no matter who measures it, no matter how fast you are moving. Let me give you a specific example. You are standing still. You turn on a flashlight. You measure the speed of the light coming out, 299,792,458 meters per second. Fine. Now you get on a train.
a fast train going at half the speed of light.
You shine the flashlight forward in the direction the train is going. Common sense says the light should now be traveling at the speed of light plus the speed of the train.
Just like if you throw a ball forward from a moving train, the ball will move faster than if you threw it while standing still. But that's not what happens.
You measure the light, and it still travels at 299,792,458 meters per second, the exact same speed. You tell yourself, maybe I measured wrong. So you make the train go even faster.
Hit 90% of light. You shine the flashlight forward again. You measure. Still 299,792,458 meters per second. You get annoyed. You put the train up to 99.999% the speed of light.
You turn on the flashlight. You measure. Still that same speed. The speed of light doesn't add up. It doesn't combine with your speed. It always stays the same, no matter how fast you are moving. This should make your head hurt. This is not how speed works in everyday life. Speed is additive. If you are on a train going 50 miles per hour and you walk forward at 3 miles per hour, you are moving at 53 miles per hour relative to the ground.
But light doesn't do that. Light always moves at the same speed relative to you, no matter how fast you're moving. Why? Einstein realized what was going on.
And it's so strange, so counterintuitive, that even now, more than a century later, people still struggle to accept it. Time and space are not fixed. They are flexible.
They bend and stretch to keep the speed of light constant. When you move faster, time slows down for you. Your clock literally ticks slower, and distances contract.
The space in front of you compresses. These effects are real. They are not optical illusions. They are not measurement errors. Time actually slows down.
Space actually contracts, and they change by just the right amount to make the speed of light the same for everyone. Let me say that again. The universe adjusts time and space, bending them, stretching them, compressing them to ensure that light always travels at the same speed for everyone. The speed of light is not just a velocity number. It is a structural constant of the universe. Space and time are arranged in a way that this speed is the same for everybody. Now, here is where things get even weirder.
If you try to accelerate something, anything, up to the speed of light, a very strange thing happens. The closer you get to the speed of light, the harder it becomes to go faster. Not because you ran out of fuel, not because your engine isn't powerful enough, but because the object itself increasingly resists acceleration. We call this relativistic mass increase.
As you go faster, your inertia increases. It becomes harder and harder to push you faster. And as you approach the speed of light, your inertia approaches infinity.
To actually reach the speed of light, you would need infinite energy, which is impossible. So nothing with mass can reach the speed of light, not because of some arbitrary rule.
Nor because of technical limitations, but because the very structure of space-time prevents it. Light can travel at that speed because photons are massless.
Zero. Massless particles can travel at the speed of light. In fact, they must. They have no other option. They always move at that speed. But anything with mass, it can only get close.
Very close, 99.9999% the speed of light, but never reach it. The universe won't let you. Now, you might ask, but why? Why is the universe set up this way?
Why is there a speed limit? And this is the answer that will leave you hanging. There isn't a deeper why. The speed of light is not a speed limit imposed on the universe.
It is a consequence of how the universe is put together. Space and time are not separate. They are woven together into space-time, and space-time has a geometry, a structure.
And that structure has a built-in conversion factor between space and time. That conversion factor is the speed of light. It's not because light is special.
but rather that space-time has a maximum speed at which cause and effect can propagate. Light happens to travel at that speed because light is massless, but the speed itself is a property of space-time, not of light.
If light didn't exist, that speed limit would still be there. It's a feature of the universe itself. Here is another way to think about it. In everyday life, you think of space and time as separate things.
You move through space, time passes. They are independent, but they aren't.
You are always moving through space-time at a constant speed. Always. But that motion is shared between space and time.
If you are sitting still, all your motion is through time. You are heading into the future at maximum velocity, 1 second per second. But if you start moving in space, you have to redirect some of that motion away from time.
Now you are moving through both space and time. That means you are moving through time slower. The faster you move in space, the slower you move through time.
And there is a maximum limit. If you could move in space at the speed of light, you would have no motion left for time. Time would stop for you. This is why light doesn't experience time.
From a photon's perspective, it is emitted and absorbed in the same instant. No time passes. The universe is frozen. You cannot go faster than light because you cannot have less than zero motion through time.
That is the limit. That is the wall. And here is the beautiful part. This is not just theoretical speculation. We have verified this over and over and over. Particles in accelerators are boosted up to 99.9999% the speed of light. And guess what? The closer they get, the harder it becomes to accelerate them further, exactly as predicted. GPS satellites have to account for time dilation.
They move fast and are in a weaker gravitational field, so time passes differently for them than for us on the ground. Without adjusting for this, GPS would be off by miles in just one day.
Muon particles created high up in the atmosphere by cosmic rays should decay before they reach the ground. Their lifespan is too short. But they are moving near the speed of light, so time slows down for them.
From their perspective, they live long enough to hit the ground. From our perspective, they live longer because they are moving fast. Either way you look at it, far more muons hit the ground than should, exactly as relativity predicts.
That's not speculation, that's measurement. The fact that the speed of light is a limit is as thoroughly tested as anything in physics. So let's summarize. Why is the speed of light the limit?
Because space-time is structured in a way that there is a maximum speed for the propagation of cause and effect. That speed is the speed of light. Not because light is special, but because space-time itself has this built-in conversion factor between space and time. You can't go faster because going faster would require moving backward in time, which makes no sense. You cannot have negative time. You cannot undo cause and effect.
The speed of light is the speed at which the concept of now propagates across the universe.
It's the speed at which information can travel. It's the speed at which forces act.
It is the maximum rate of change. And this process, this wave of discovery, started with Newton figuring out gravity by observing the moon. Then Romer figuring out the speed of light by observing the moons of Jupiter.
Then Einstein realizing that the speed of light was constant and deducing relativity from it, followed by thousands of experiments confirming it, each discovery building upon the last.
Each new insight opens the door to deeper understandings. That is how science works. That is the wave that has continued for the last 400 years, and we are still riding that wave at high speed right now.
The speed of light is not just a number. It is the key. It is what unlocks how space and time operate. It is what shows us that the universe is stranger and more beautiful than we ever imagined.
And the fact that we can understand it, that we can measure it, verify it, and use it to make predictions, that is the beauty of physics.
Not comfort, not simplicity, but truth.
If you liked this video, you are definitely going to enjoy our next content. So hit that subscribe button and turn on notifications so we can bring you more fascinating content in the next video.